So we have a graph here that shows the height of an object as a function of time. So if we zoom in on this graph, it looks like the object goes up for a little while, reaches a peak, which is sometimes called the vertex. It is the highest point that the graph reaches, and then it goes back down. And what we want to do here is we want to interpret these features, the features of the graph. First, we want to identify whether the function is linear or nonlinear. And then after we do that, we want to estimate and interpret the intercepts. So when we talk about intercepts, there are two that are labeled here. One is the y-intercept and one is the x-intercept. So first, let's identify the function as being linear or nonlinear. And that's really easy to do because linear means it's a line and nonlinear means it's not a line. And it's pretty obvious when we look at this that it is not a line because it curves, it goes up and then it goes back down. So we would say that this is non-linear. And the reason why is the graph is a curve, not a line. The graph is a curve, not a line. Great. Okay, so now let's take a look at the two intercepts, and we're going to talk about what the intercepts are, meaning we're going to estimate values for them, and then we're also going to describe what they mean in context. So let's start with the y-intercept, which is right here. And the graph is really not detailed enough for us to tell exactly what the y-intercept is, but if I had to guess, I would say it's about 15. It looks like that's right in between 10 and 20. So I'm going to estimate that the y-intercept is 0, 15. So there's my estimation of what it is, 0, 15. But what does that mean? Well, this graph is showing me the height of an object that is being launched, and 0, 15 means the x value is 0, and on the x-axis we are measuring time in seconds. So that means 0 seconds, and the y value of 15 on the y-axis we're measuring height in meters, so it means 15 meters. After 0 seconds, the object is at 15 meters off the ground. So that means the object started at an initial height of 15 meters. So we're going to say the object started 15 meters off the ground, we'll say. We don't know if it's really the ground, but from wherever it was launched, it was 15 meters above there. We should, if we were good mathematicians, in fact, let's be good mathematicians, we'll say the object started with an initial height of 15 meters. We don't really know if it was off the ground, like it could have been from the top of a building or a platform or something. 15 meters from the launch site, we don't know. Probably the ground, but we can't say for sure. So now let's look for the x-intercept, and the x-intercept is right here. And the x-intercept looks like it's a little more than 7. It doesn't look like it's exactly in the middle. Let me erase that dot I did so we can see a little closer. I would say 7.5 would be right there. It looks like it's a little before 7.5. So maybe like 7.3 or 7.4. I'm just going to call it 7.3 just because. 7.3 seems like a reasonable estimate. So that means the x, the time, is 7.3, so 7.3 seconds. And the height is 0, so 0 meters off the ground. So after 7.3 seconds, it is 0 meters off the ground, or off the landing spot, whatever it is. I'm just going to say ground accidentally, even though we don't know that it's the ground. So we would say for this x-intercept, the object lands, after 7.3 seconds. And that is where the object starts. It starts 15 meters as its initial height, probably off the ground, and then it lands after 7.3 seconds. So we shoot the object up in the air. It goes up to some kind of maximum height, which is called the vertex. That's this height right here, whatever the maximum is. And then it comes back down, and from the time it launches to the time it lands, it takes a total of 7.3 seconds.